Well, hello guys, Mr. G here with another question for the grade 12. We are going to still be solving the question paper of June 2016 in the Free State and Northern Cape province. This time we're going to be doing question 4. Last time we did question 5 and we also done question 6. So we're going to go to question 4, and this question is mostly about momentum but also work, energy and power. Now before we carry on, please don't forget to subscribe so you can get all the videos I post on regular basis, some very fun videos and some videos that will help you to understand better physics. But anyway, question 4 say Percy, mass 75 kg, rides at 20 meters per second on a quad bike. A quad bike is a motorcycle with 4 wheels with a mass of 100 kilograms. He suddenly applies the brakes when he approaches a red traffic light on a wet and slippery road. The wheels of the quad bike lock and the bike slides forward in a straight line. The force of friction caused by the bike to stop in 8 seconds. So there is a force of friction which stopped the bike in 8 seconds. Define momentum in what? Now to define momentum, last time we spoke about momentum, which is in the formulas. And here is still the formula we were talking about. These formulas, guys, I'm going to say it again, is the definition for momentum. All you have to do is to be able to write that formula in words. So let's start by writing the formula. You don't have to do that. You only read the formula, but I'm going to write so you can see how to write that one. So that is the formula, and you have to say that momentum is the product of mass and velocity of an object. That is what we called momentum. Product of mass and velocity of an object. Very simple. Remember that definition is in the formula which is given to you in the exam. So the answer is being given to you. All you have to do is to make sure you write it in words. Question 4.2, calculate the change in momentum. Now, change in momentum, guys, change in momentum, any change in physics will be equal to final momentum minus initial momentum. Any change in physics is final minus initial of Percy and the bike from the moment the brakes lock until the bike comes to stop. Now, let's answer this question 4.2 here, but we as usual, I'm going to write down the data we have there. Okay, I'm going to write all the data and I'll be back just now. Okay guys, here is the data. The mass of Percy, the mass of the bike, together there is a mass of 175 kilograms. The initial velocity of the bike with Percy on is 20 meters per second. I wrote forward the final velocity 0 because stop delta t is 8 seconds, and then you are looking for the change in momentum. That is question mark. Remember, I told you change in momentum is equal to final momentum minus initial momentum. So if you substitute the formula for momentum in each case, you have that the change in momentum is equal to mass multiplied by the final velocity of the object minus mass multiplied by the initial velocity of the object. In this case is Percy and the bike. And then guys, the rest is to substitute everything because we have everything given to us there. So change in momentum, and I am going to substitute. You get that the final answer is negative 3,500 kilogram meters per second. This minus means direction. However, I am going to write it in words because you know sometimes you don't get mark if you write it or leave it like that. So we are going to write change in momentum is equal to 3,500 kilogram meters per second in the opposite direction. All right, and this is the answer for question 4.2. It's an important question because we done this one at the beginning of the year, and I don't know if you ever practice it again, but it's going to be in the June, it's going to be in September, and it's going to be at the end of the year. So please make sure you practice. Let's go to question 4.3. 4.3 say calculate the average frictional force exerted by the rod on the wheels of the stop to stop the bike. And if we go here on top, I want to do it on top because of the space, and we draw the free body diagram. I just want you to do this one real fast. Let's say this is the forward direction and this is the y-axis, and then what forces are acting on that bike as the bike is stopping. So there is friction backward in the opposite direction. This is frictional force. There is the only force in the x-axis. There is normal pointing straight up perpendicular to the surface, and there is weight, and remember weight must be more or less the same length. It must be in actual fact the same length. So guys, the net force here that is acting on the object is going to be the frictional force. I want you to note that one there. So we are going to go and we are going to combine a couple of things here, and this is for question 4.3. Now, first of all, we are going to go to the formulas. And here we are. There are two formulas in which we have the net force. One of them is Newton's second law of motion, which is this one here. This is Newton's second law of motion. And this one here, which is in other words the definition of impulse, but this one is the one we are going to be using. You can see here also the change in momentum, guys, is given to you. Now here we're going to use that formula to calculate the average force of friction. So here we are. The force, net force, which in this case is the frictional force, is going to be multiplied by the time, is going to be equal to the change in momentum of the impulse. I'm going to write here J, and this J is for impulse. This is impulse. This is the symbol of impulse. And guys, this is in actual fact the definition of impulse. But there is a theorem which is called impulse momentum theorem, which said that impulse is going to be equal to the change in momentum. So here we have this one, and if we substitute there, then we can have that the net force is going to be multiplied by the time, is going to be equal to the change in momentum. This one is given to you. This formula is given to you in this specific way, but I wanted you to see that one. We already have the change in momentum, so all we have to do is to substitute what we actually have here. The final answer is going to be 437.5 Newton negative. Let's write the negative there. Let's write the negative there. 437.5 Newton. This one is negative, and guys, that is the final answer for the average frictional force that you can see there. Quite simple, it's not that bad. Okay, let's go to question 4.4. Write down the work energy theorem in words. Another 2 marks that can be given to you. The answers are there. So in this question, solve something very important. In this question, there are 4 marks given to you, in which the marks are, or the answer is in the question paper. So if you go to the formulas again, we are here. This one here is the work energy theorem. Work energy theorem there. And all you have to do is to use it in the answer of the definition, or state the work energy theorem in word. We are here. State work energy theorem in word. If we write it here, is the net work is equal to the change in kinetic energy. That is the formula, and that is the work energy theorem in word. Make sure you write it in word. That theorem states that the net work acting on an object is equal to the change in kinetic energy. Net work equal to the change in kinetic energy of the object. The answer for that one is given to you. Calculate the work done by the frictional force to stop the bike. And to answer this one, we are going to be using the work energy theorem. It's very simple. I think we're going to have enough space here because it's very, very simple. So to do that one, we're going to start with the work energy theorem, because the only force acting there that does work is the frictional force, work done by the frictional force. But you must start with the work energy. This is no momentum, it's energy, kinetic energy. So all you have to do is now change this one to work done by the frictional force, and this is equal to half mass final speed square minus half mass initial speed square. And all you have to do is to substitute. And the final answer is negative 35,000. This is the answer for this question and the final question of this video. Very simple. I hope it helped. I hope you get some clarity. I hope you manage to practice. I recommend you now to do this question using the work done by the non-conservative forces. So you can practice work done by the non-conservative forces is equal to change in kinetic energy plus the change in potential energy, but at the end you will end up having the work energy theorem. So this one is the end of the video, guys. I hope it helped. If it did help, please subscribe for the channel so you can get the notification all the videos I post on regular basis, as well as the worksheet. Thank you for watching. Mr. G here. I'll see you next time.